Welcome. In this video, we will explore advanced location models in facility planning, from emergency response unit to shopping malls. My name is Birles, and let's get started. We will focus on two critical models, set covering model and the absolute center or minimax model. These help us strategically place emergency services, public facilities, or distribution networks to guarantee optimal service delivery, especially when every minute or mile matters. The set covering models aims to minimize the number of cost of facilities need to be ensured every demand point is covering with a specified distance or time. It is widely used for services like fire station, ambulance depots, libraries, and schools. Let's start with a real-world example. A rural county of 100,000 people wants to place emergency medical response units so that any call can be reached within 8 minutes. Speed is 60, so that's an 8-mile travel limit. The county is divided into 7 population zones. Units can only be placed at zone centers. Here's the distance matrix and the cost to be placed unit each zone from 80,000 up to 120,000. First, we build a convergence matrix. Aij is equals to 1 if the distance from I to zone J is smaller than 8. Then we apply greedy heuristic for each candidate zone J. We compute cost per covered zone Cj divided by Dj. Zone 2 gives the smallest ratio, which is 16. So we place a unit in zone 2. It covers zone 1, 2, 5, 6, and 7. Remove those left uncovered zones R, 3, and 4. Now only 3 and 4 need to be covered. We recompute ratios. Zone 4 has the smallest, which is 55. So we place a second unit there. The final solution is units zone 2 and 4. Total cost is 190 million or 19 million. All 7 zones are within 8 miles, at least 1 unit. This is the set covering model. We minimized cost while covering every demand point within a given distance. Now, the second model is P-center. Instead of covering within a fixed distance, we fix the number of facility P and minimize the maximum distance from any demand point to its nearest facility that guarantees the worst case response time is as small as possible. Let's compare. Set covering minimizes cost or number of facilities given a convergence distance, perfect for fire station or schools, where you must cover everyone within a fixed response time. P-center minimizes the maximum distance given a fixed number of facilities, ideal for balancing service quality when you have budget for exact P ambulances or helipads. Now we move to a more general model. The uncapacitated location-allocation model decides which facilities to open and how to allocate customer demands, minimizing fixed opening cost, plus transportation cost. There is no capacity limit. That's uncapacitated means. Here is notation M, potential facilities, and customers. Cij transportation cost, Fi is the fixed cost, Dj is the demand. Variables are Xij, units shipped from facility I to customer J. Yi is if the facility is open or not. The objective function as fixed cost plus variable transportation costs. Each customer demand must be met, and you can only ship from a facility if it's opened. This is a mixed integer linear programming solved with branch and bound, often solved with branch and bound. Here's a tiny example. Two warehouses A and B, fixed cost 1,000 each. One customer with demand 500, transportation costs are A 2 unit, B to customer is 3 unit, 3 per unit. Opening only A gives a total cost of 2,000, and opening only B, total cost is 2,500. Both is even more optimal. Open only one, which is A. The comparison model adds real-world complexities, multiple products, multi-stage distribution, plant to warehouse, warehouse to customer, upper and lower capacity limits, and the restriction that each customer zone is served by a single warehouse for service quality. We have new indices, I for product, J for plant, K for warehouses, I for customer zones, fixed costs, FK, variable costs, variable handling costs is VIK, product capacity is SIJ, and demand is DIN. Our binary variables are YKN is equals to 1 if warehouse K service customer zone N, and the ZK if it's equal to 1 if warehouse K is opened. And the objective minimizes total production, transport handling, and fixed cost constraints, ensure plant capacity is not exceeded, demand is met, each customer zone is served by exactly one warehouse, and warehouse throughput stays within lower and upper bounds. This is large scale and will be typically solved with advanced optimization software. That wraps up our tour of advanced location models. Thank you for watching.